Comparing rational numbers. The easiest way to compare rational numbers, such as the ones you see here, are to turn all of them into decimals, as decimals are going to be the easiest way to compare. 9.02 is already a decimal. To turn 9.2% into a decimal, we had to divide by 100. We get 0.092. Before we can compare, it is always good to have the same amount of digits after the decimal point. As you can see here, we only have 2, and over here we have 3. You can put a 0 at the end of this decimal, so now we are ready to compare. Starting from the left, we can look at the numbers in front of the decimal. 9 is bigger than 0, which makes this entire decimal bigger than this one. So we will use the greater than symbol. The alligator always eats the bigger number, or however you like to think about it, but this number here is the greater number. For our next example, I've already turned both of our numbers into decimals. This time we have negative numbers. When you compare negative numbers and both of the numbers are negative, everything on the negative world is always the opposite of what's happening in the positive world. So if a number is bigger in the positive world, it's actually smaller in the negative world. Before I compare, I added my 0 here, so now I have 0.60 negative and negative 0.65. In the positive world, 0.65 would be bigger, but since we're in the negative world and everything is opposite, this is actually our smaller number, making this larger. It is larger because it is closer to 0 or closer to the positive side. It is more right on a number line. Here we have 2 decimals. This one has 3 digits after the decimal point, and this one only has 2. Anytime you're going to compare decimals, make sure there's the same amount of digits after the decimal point. As you can see now, these 2 numbers are equal. At first, you may have thought this one was larger because there was more digits, but you need to be careful with that. Make sure that every time you compare, they have the same amount of digits after the decimal. Okay, so we have 2 positive numbers. We have 0.4 and 9/40. I've turned this into a decimal already. Before we can get started, I want to add 2 zeros to the end of this decimal so that now both of our decimals have 3 digits after the decimal point. Using the same method as before, I'm going to look at the number in the ones place. Here we have a 0 and a 0. We cannot use this to compare as 0 is the same number, so we can't tell which one is bigger or smaller. So we're going to move over to the 10th place. In the 10th place, we have a 4 and a 2. Since our numbers are both positive, we look for the bigger number. Our bigger number is 4, making this our larger number. As you can see here, I've already turned 2 3/4 into a decimal, and I just brought this one down. Before we can get started, we need to put a 0 at the end of this decimal to be able to compare. As you can see here, the first 2 numbers are the same, so I went over to the 10th place. 7 is greater than 6, so our first number, 2 3/4, is greater than 2.624. I always like to look for the greater number first. It just helps me know which way my symbol needs to face. I have turned both of these into decimals, and as you can see here, we have negative 4.3 repeating and negative 3.3 repeating. Well, in the positive world, negative 4 would be greater, which means in the negative world, it is smaller. So our negative 3.3 is greater, so our symbol will face this way.